Hi everybody, this is just a quick video on 9A1. Let's talk about the first problem. Here we're going to test if the point 1/2, 1 is going to be a solution of both, and the answer is that it's not. It's because although it does satisfy the first equation, it doesn't satisfy the second, and it's got to satisfy both equations in order to be a solution to the system. So the answer is no, it is not a solution to the system of equations. Let's take a look at number 3. If you graph both lines on the same axis, then you can see they intersect right here. And if you've got a great grapher, then you can just line it up and you can see right there. If you want to do it by hand, you can. It's good to check to make sure. Like you would have to, if you're going to graph this by hand, you have to be kind of an architect and be exact on where you graph so that you find the intersection. But anyway, you can check what you find, and then you see that the solution is -1, 3. Number 6, they start off with equations that are not exactly simplified or solve for y, especially if you're going to graph. We all know that graphing is a lot easier often when you solve for y, especially in these two equations. So you solve for y. For here, you can subtract 1 and get this equation. You subtract 1 and you get this particular equation right here, and then divide this one by 3 and you get the same equation. So if you're going to graph the same equation twice, you can see they completely coincide with each other. They are overlapping and occupy the same space on the graph, so therefore there are infinitely many solutions. Each and every single one of these points is a solution to the system of equations. Number 18. The unknown, we don't know what these two numbers are, so let's call them x and y. And once we do that, once we pick letters from the alphabet, then we can see that it's much easier to construct these equations. When you add them up, you get -1, and when you subtract them, you get 10. Looking at these 4 different variables right here, I think the easiest one to solve for would be x right here, because when I add y to both sides, it becomes 10 plus y, and we like addition. So x is equal to 10 plus y. I use 10 plus y in the unused equation, which is the top one. And so I'll rewrite the top equation again. X plus y equals -1. Instead of writing x, I write what x is equal to, 10 plus y right here. 10 plus y is equal to -1. And when I solve that, I get y is equal to -11/2. And then I use this information here in, say, this equation right here. Like I take this information and rewrite it here. So x is equal to 10 plus y. Well, I know what y is. X is equal to 10 plus -11/2, which happens to be 9/2. So this is the answer right here. Number 20, we don't know what the speed of the plane is or the speed of the wind, so I'm going to use P and W. Well, that's actually what the textbook's answer solution chooses. Distance equals speed times time, or rate times time. And then relating these two together, you see that you have to multiply. So P plus W times 3 is that, and then P minus W times 4 is that. I'm going to divide the top equation by 3 to get this, and the bottom equation by 4 to get this. I'm going to solve the bottom equation for P to get P is equal to 750 plus W, and I'm going to take 750 plus W. Oh, I wish I'd used parentheses right here. And use it in the unused top equation. So I'm going to rewrite the top equation again. 750 P plus W is equal to 1,000, and instead of P, I'm going to write 750 plus W. So here, 750 plus W, that used to be P, and now plus W is equal to 1,000. When I solve this bottom equation, you combine the like terms. 2W, I subtract 750 from both sides and divide by 2, and you get W is equal to 150 kilometers per hour. And once I know that, then I can substitute it in here. P is equal to 750 plus 125 to get 875. And there it is, folks.